Hello Internet and fellow network engineers. My name is Maxim. I share network tips and tricks with you on my channel. This is the video number 3 of the series dedicated to securing IoT or Internet of Things. This is a bonus content video for the most patient of you. First, I'll give a brief example of miscellaneous recommendations from me, and then I will show you how you can do your own one of these Raspberry Pi Zero with the image of Pi-hole step by step. I'll show you every single step, including physical connection, provisioning of micro SD card, and the basic configuration and basic maintenance. So, without further ado, let's get started. Just a few of my personal recommendations with the IoT devices. Check your firmware updates for your devices regularly and keep them updated. If you use voice assistants, make sure that they don't allow to unlock your smart door lock or disarm your home monitoring system with a simple voice command. Disable this functionality or set a PIN code. Set automations to enable indoor camera recordings only when you are away. Enable camera LEDs to add visibility when your cameras are recording, so protect your privacy. Be extra careful with hazardous IoT devices. There are such things like smart stoves, heaters or fireplaces. Try to avoid using automations with them. Try to avoid allowing them to automatically turn on. Regularly verify the safety of those appliances, that the plug is snugly connected to the outlet, that you don't have heater covered with the clothes or similar things. So don't cause or don't increase your risk of fire. Use vacation mode with your smart lights. They will automatically turn on and off, simulating human activity inside your house while you're awake on your vacation. Okay, we'll start our process to set up the Pi-hole on Raspberry Pi Zero. You can see my current lab setup. I have SRX 300 over here. The internet is connected to port 0. Port 1 is connected to PoE injector, which is powering the AP. And we are basically ready to prepare our Raspberry Pi itself. So this is the Raspberry Pi Zero, which we'll be using. Again, it is plenty performance what you need, but currently there is a more modern version too, Raspberry Pi Zero 2W. There is a model without W and with W. The difference is the wireless chip on board, Wi-Fi chip. You have an option to connect it via Wi-Fi to the AP, but I still prefer to use wired connection. So I will show you all the details step by step. So the next step is we need a micro SD card and we need a micro SD card reader, so which we'll use to install the firmware on this card for it, and then we'll handle the connections later. So let's start. So I'm going to show you the browser. So it all starts here in the browser. What I'm going to type Raspberry Pi Imager, and you just go the first page, which is raspberrypi.com software, and then as soon as you are here, you immediately see a link to download Raspberry Pi Imager. So this is a special software which will automatically provision your card for you. So it is made very simple. So you click download for your operating system, you download it, and then you open it. You take your micro SD card reader, insert your card, and then you connect it to your computer. So, as soon as you do it, now in the Raspberry Pi Imager, we have an option to choose the device, and in our case it is Raspberry Pi Zero. If you have 02, you will select it over here above, but in my case it's 0. and then I'm choosing my operating system, and you can see something recommended in the top. We don't need it because we don't need the desktop. So we'll go down here and we'll use Raspberry Pi OS Other, and then we'll use something called Raspberry Pi OS Lite. So we don't need the full functionality, we need the lightweight operating system. We'll use Raspberry Pi OS Lite 32-bit. And then we selected the model of the device, we selected the version of the OS, and then we need to choose storage. And we select our card. In my case it's 16 GB card. You can go higher, whatever card you have. Yep. And then it asks you, would you like to apply customization? And we do. So we go edit settings, and we would like to change the host name. So we'll name our card and say PiHo1. And then we would like to set username and password. Lab123. We don't want to configure wireless LAN in this case, but it is an option if you'd like. And then you can set your local parameters. Then we go to services and we enable SSH with password authentication. In this case we'll be able to SSH to it later. Then we go options, and this is just non-related stuff. Yep, this is all good and ready, so we click save, and then we would like the customization, apply customization settings, yes, and then it tells us that the card will be erased and we would like to continue. So then it will take a few moments. It's done. So we are going to safely extract our USB stick. So now we have our Raspberry Pi, and we have the card with the image. So we insert it from this side, and now we need to make a connection. So over here you can see two micro USB interfaces. So one on the right is the power port, so we'll need to connect power here. One on the left is the data, so we'll be using it to connect to the network. So you may ask how we do it. Let me show you. So for the power it's pretty easy. We have micro USB to a regular USB to provide power. 1 amp 5 volt power brick, like standard, will be sufficient. And then what we need to a micro USB to Ethernet adapter. So initially, like in my practice, I started with something like this, ordered no name adapter. So this is not working well. It is usually negotiating at 10 megabits per second. So I don't recommend using something like this. Instead, in my lab, I usually use this one. It's not sponsored, but just I use this. It is 100 megabits per second. It is a well-known brand, and it requires an external power as well, so to make a connection. So this is how it looks like. This is where you connect to Ethernet, and then there are two cables. One is for USB, regular USB-A for power, and micro USB for data. So now we are going to make our connections. So we'll connect power. And we are are going to prepare our network. So the Raspberry Pi is already booting. You can see it by looking at the green LED over here. So we'll let it boot for a while. Meanwhile, we'll connect to SRX and I'll show you what pre-configuration we'll need to do on the SRX. Okay, we are in SRX interface and this is what we need to do. So our interface 2 is pre-configured to be an Ethernet port in the VLAN DMZ. Yep, port 2 currently is in down state, but it is in the DMZ VLAN. So we can do show interface source IRB 40. This is the address. It is pre-configured there, but this is the thing. So when it will boot up, you saw when we did imager, there was no option to set an IP address. It means we need to provide the IP via DHCP to the Raspberry Pi before we can set it and change it to static address. In order to do that, we need to configure interface to be listening for the DHCP request. So we need to mention it here in system services. This is always step 1 when you configure DHCP. So next step, we need to double check that our security zone allows DHCP. It does. And then we do edit access, address assignment, pool DMZ pool. And we end it. So we are going inside that hierarchy level. Currently it's empty. So we are going to do network 192.168.30.24. Then we need to create a range. And usually for DMZ I prefer to keep it small, because then I usually change it to static addresses. In this case I will do 3200 to 210. So just 11 addresses. Okay. We configured range. Now we do DHCP attribute name server. So we'll just point it to the internet. And then we'll do router. Let's have a look. Looks good to me. So this is enough to make sure the DHCP is working. Let's do the commit. Commit is completed. So we'll be monitoring server binding, match IRB 40, right? And we'll do refresh 5, so it will automatically refresh the screen. And I will start doing the connection over here in the lab, right? We have power already connected, so now we need to connect the network. So let's do it. So I have a patch cord here, so I will connect it over here, and then I will connect it to port 2 for our DMZ. One side of this is already connected to power via USB-A and the micro USB data, so I'm going to connect it to the board. Something I noticed that the link doesn't come up immediately. so we'll need probably to wait or reboot the Raspberry Pi, so we'll see. But don't blame your USB Ethernet adapter just yet. Yep, you can see the LEDs, the link went up. Just be patient when you do this step. Okay, and you can see in the SRX screen it got the address, it got 200 address. So now we are able to connect to it via the wire network. Another step which we can do 002 match speed, and we can confirm that it is actually running it in speed 100 full duplex. So, and I forgot to mention that if you will buy and use something like this, they actually have the same exact MAC address. They don't do it properly by providing unique MAC addresses. So what I did initially, I purchased 3 of these white stuff, and then I put 3 Raspberry Pi Zeros in the same subnet. And what I had a MAC address conflict, and which was bouncing between the ports, and I was troubleshooting it for a while. I haven't expected that the adapter will have the same MAC address repeating on multiple links. So don't use this white stuff, like purchase something of a known brand. Okay, yeah, so another thing useful, basically we are on SRX right here, right? So we can just SSH from the SRX right to the board. So just have a look. So we can first ping 192.168.3.200. Yep, so we can ping it, and now we can SSH. And remember the login and password which we set when we used the imager. So we used lab123. So we will use it to connect to it. So there is no default login and default password in Raspberry Pi anymore for the security reasons. Okay, we are inside. So here are the steps which we'll need to do. So first of all, the command which is sudo raspi config. So this is the config built into the operating system. The way to set certain parameters in a nice format. So what we need to do here, and what I recommend touching here. So we can go to basically you just go through. So we go to Raspberry to system options. Right? Yeah, system options. And then you can set your wireless LAN if you'd like. Here you can change your password here, right, for your lab user. So we won't change it, but again, this is an option. You can change your host name. Yeah, so these 2 options, consider them if you need them, or if you forgot to set it properly when you used imager. Let's do back. So then, so let's look at the display options. Again, this is not something I change. So then we can go to interface options. You can disable SSH here. So this is a nice option. So if you would like to basically switch to the bottom, select and back, you use tab. Performance options. Yeah, so not something I would do. Localization options, we have already set it in the imager, but again, something you can change over here. So, but what we need to do, we need to go to advanced options, and here we need to expand file system. So basically, by default, when you use an imager, it uses just a small portion of your card, just necessary to provision the image. But in our case, remember that Pi-hole later will be storing large log files, query logs, and you would like to keep them for a while, right, to be able to go back. In this case, you need to expand your file system to the whole size of your SD card. So this is what I recommend doing. You just click it and just wait. Hit enter and wait. Yep, it has been resized. The file system will be enlarged upon the next reboot. So what we need to do now, we'll do a reboot. I hit finish. It asked me to do a reboot. Let's do a reboot now. Okay, the Raspberry Pi is back. So we are going to SSH to it and keep going with our settings. So next step will be we'll run the update of the packages. Again, this is something to note. So for my production, I currently use the modern version, which is Raspberry Pi Zero 2, and it is much faster because it has quad-core CPU compared to this small guy. But again, it's for the Pi hole, this is good enough, especially if you don't use it, let's say, for the whole network and just for the IoT. I'll do upgrade. Okay, the upgrade is completed. So next step is to check our networking and set the static address. So we'll do an MCLI. The goal is we need to double check the name of our interface. Oh, it's over here. So our interface is called Ethernet 0, ETH0. So the command will be sudo nmcli con name. This is basically the name of the connection, so we'll call it primary. IF name Ethernet 0, so this is our interface. Type Ethernet IP4 192.168.32/24 GW4, this is our gateway, 3.1. Okay, so we set static address. So next step is sudo nmcli connection modify primary IPv4.dns quote, and then we'll provided our DNS servers. And next step is to do a reboot. The ping is successful, and you can notice that I changed the address, and now we're pinging the static address because the Pi changed its address to 3.2. So and I'm going to SSH to it using the new address. Okay, so we are in the Raspberry Pi OS is set, updated, address is set to static. So next step is to install the Pi hole. Yeah, I'm here in the browser and I go to the URL https://pi-hole.net. As soon as I'm in the Pi hole website, so I'm scrolling down and there is a link install Pi hole. So I click on the button. And then here you can see a one-step automated install method. We'll be using this method. So in order to do that, we need to copy the command, which will run, and then we are going back to the SRX, to the SSH session. Go back, and here we do sudo on the Pi hole, and then we paste our link for the one-step install from the Pi hole website. Okay. So we have some element which we need to do. So yep, we would like to transform it into network-wide DNS solution. It's free but powered with donations, so you're welcome to do that if you'd like. So again, Pi-hole as a server needs static address. Please continue when the static address has been configured. So in our case, we do tab and do continue because we have already done it. So next step, it asks us to choose the interface. So in our case, we would like to use wired interface. It's already pre-selected. I'm going to hit enter. Next step, it just provides you options which you can use as your upstream DNS provider. By default, it selects Google. I'm fine with that for now, but you can investigate other options which may be interesting for you. And I use a custom option, not the Google, for my own protection. Next, it recommends us to install the block list, a block ads list, which will be available by default. And there later in the interface, you will be able to shut or switch it off and on. So I would like to do it. Yes. Would you like admin web interface? Yes. If a web server is required for that, would you like to install it? Yes. Would you like to enable query logging? Yes. This is the setting for the privacy. In our case, because we would like to log all the devices and their queries, we would like to do 0, which is show everything, which is by default. We hit continue. Okay, so it basically shows that everything is set up and ready. It shows the IP address it's listening on, and it shows the URL which we'll be using to connect, which is HTTP, then IP address /admin, and then it shows you the admin web page login password, so which is this one in the last line. Again, you will have some shell password, which will be in our case lab123, which we set it by imager. But this is a web GUI password. So again, you write it down. I hit enter. Let's say you forgot to write it down, or you lost, let's say, your password, or you would like to change it. So in this case, your command will be sudo pi-hole -a -p. So I change my password. Okay, yep, my password is reset. So now I'm doing a final reboot. Yep, we lost about like 58 packets, so the reboot took like a minute, so it's not that long. So before going for the final verification in the browser, so I'm going to show you a few maintenance commands which you need to maintain your Pi-hole in good shape. So first of all, it will be sudo apt update and upgrade. So just don't be afraid to do that. So I've never seen any issues caused to the Pi-hole software by doing that. So just do it regularly. Next step is sudo pi-hole -up, and this is to update the Pi-hole itself, its web interface and its internals. It's also a command which I frequently run to make sure that I am up to date. Yep, so there are 3 primary components which may get outdated, right? In our case, everything looks good. These are basically 2 maintenance commands which you need. So now I'm going to switch to a browser for a final check. So I typed my URL, which is http IP address /admin, and here we are. So it asks you for the password. This is a GUI password, which we have changed with a separate command. And I'm logging in. Okay, and here we are in the web interface. So there are a couple more steps. So first of all, on the left side, you have statistics on your CPU load, memory usage, and temperature, right? And the status of the Pi-hole itself, the process. So currently it's active and listening for the DNS requests. Then if we scroll to the bottom of the page, here are the versions of these three main components which we've seen when we did Pi-hole -up. And usually if you're outdated on one of them, you will see a message over here. So it's like a nice way how you can verify that you're up to date. And also you can see you have like a notification over here in tools. And if you go there, we can go diagnostics. And here it is saying for us that, hey, we are ignoring query from non-local network. And this is like one of the devices which is pointing, IoT devices which are pointing to Pi-hole. And in order to fix it, again, this is something we've done already in the part 2, but you go to settings, DNS, and you look into this, so how you would like to process your requests. By default, it listens only to the local network, not for the remote. If you'd like to listen for the remote request, these are your options. So that's it. So now you have your own Pi-hole on the Raspberry Pi Zero. Congratulations. This is it. Now you have one of these at your home and in your network. So there are probably a couple notes I will add in the end. The process for the Raspberry Pi Zero 2W is identical to this one. That one is more powerful. If you can purchase the second version, do it. You will get even better experience. I hope it was useful and you learned something new today. Please return to my channel and you will find a lot more interesting and exciting content. See you later.